Part 3 AMP2100 from TENGDA. Okay, so the setup, it's done. We got the power straight from the transformer, AC. We are using the rectifier and the electrolytic capacitors here. Here I have the output resistor. Okay, cross your fingers. Google's on. And let's power it on. Yes. Everything's okay. Amazing. Let's check for the voltages. First, I'm gonna check the alternative, the AC current here. This is the ground. 24 volts, 25 volts each arm. Yes, 25 volts. And let me see the DC, 34.1. Well, this is perfect. The signal is perfect until it's going to, you see that? It's clipping. Okay, and push it to the maximum. It's like 13 volts and something, but the clean one is 9.5. Okay, another test to do before having a real loudspeaker is to determine now the input level. Okay, I can use that. I can use this one as the preamp output. That is the ground, and here I have the output. No signal. Oh yes. So we have a RMS of 0.11 volts, peak to peak 0.31. So I think this amplifier needs 0.5 volts or 500 millivolts for a proper. This is warm. I don't see any problem. Look at this guy. He's catching the signals in the air. Look there. It's perfect. It's even a little bit more, 10.1 volts. I guess in the clipping around 11 volts. Now it's even better. Oh yeah, it was a connection. Man, this is crazy. Yeah, but I can see very clear up there the clipping. No, 9.5. Let's not push it. Temperatures 32 degrees, 65. Okay, 80 degrees on the transistor brick. It's like 36 on the... Anyway, I can tell you, I can touch the heatsink without problems. Oh, man, this is something wrong. The transistors are very, very hot. At least this one here. It's like 100 volts, 100. Look at this guy, 85 degrees. I think it's more than 95. And that makes me wonder if this mica is the real stuff or is just a piece of something, you know, because now I don't trust anything anymore. I really mean that. The transistor, it's damn hot, 84 degrees, but the area around 123, come on. Wow, it's really hot. So like I said, I think there is a problem with that mica stuff. Yeah, I can. The heatsink, it's okay. We have to take someday a test about that kind of, you know, this kind of heat conducting, isolating stuff, you know, electric isolating and thermically. Okay, now let's have the final test. And that's why I'm gonna have this thing, you know, connected to the output. So we already find out the maximum signal for clipping 9.5 volts on this resistor, of course. We'll do the mathematics a little bit later. Now let me connect with the first loudspeaker there, the first cabinet, 8 ohms. We got signal there, power on. Wow, much better than the simple resistor. I need to go on 10 volts here. Power on. Okay. It's so loud. 18.4. Amazing. You see, that's why we should do the tests with real loudspeakers, not resistors, you know, because we have these impedances and all the other stuffs. They're very important. 18.4. And it's not so funny. It's not hot anymore. So maybe there was something wrong with my resistor. I need to check that resistor. I think that it was much lower than it should be. Here I have my impedance meter, low resistance meter. This one is marvelous because it's injecting an 1000 hertz, 1 kilohertz frequency into the resistor, and it gives a really good number. Okay, so we got this guy here. Okay, so remember 3.55 ohms. Just one loudspeaker connected now. Let's check the impedance. You can hear the tone already from this guy measuring 10.73 ohms. Let's do the test again. 18.2 volts. Temperatures, no problem. 18.2, okay. Let me hook the other loudspeaker. 5.7. Around 15 volts. Okay, let's change the frequency. Man, it's so loud. You can't believe it. 100 hertz. This connection is crazy here. Like 16 volts. Yeah, right. No hit. No problem with hitting. Funny and very nice. This is beautiful. Okay, time for music. So far so good. So we are on 5 ohms now, remember that. I can't say it's a very high quality of the sound, but maybe it's because my preamp here, and like I told you, this preamp it's for guitar, you know, it's how can I say, tweaked for guitars, and that's why it's pretty colorful with distortion and stuffs like that. You know, the sound it's amazing nice for the guitar, but not exactly glad with what's happening in here. That's why I'm gonna try to have a direct output from my phone to the amplifier. So far I know that my phone is delivering 0.3 volts to the output, so that should be enough. Much better, yeah. So my preamp was the source of the mod into the sound. Okay, so I think that's it for today. It was a really nice experiment that proves that little amplifier, it's working somehow. It's not the best, of course, but it's working. It's doing the job. We'll take the numbers in a split of a second and we'll talk about this at the end. Okay, so we'll be surprised about the final results here. So we have the first test with a load of 3.55 ohms, right? You know, the passive resistor. And if we take the formula wattage in RMS wattage, which it is the most important one, it's voltage RMS power 2 divided by the resistance. So in our case we have, like, if you remember, we had in the first test 9.5 times 9.5, so we have here 9025 divided by 3.55. And that gives 25.4 watts RMS, which is way under estimation. But everything, of course, happens at 33 volts. Okay? Second, we have one cabinet. One cabinet whole resistance here was 10.78 ohms. And now we have like, and the output, of course, 18.2 volts RMS. 18.2 times 18.2, that means 331.24 divided by 10.73 equals 30.8 watts RMS. Okay. Number 3, we have we had two cabinets, 5 ohms, and the output was 15 volts. Okay, 15 times 15, 225 divided by 5, and that gives 45 watts RMS. That's it, people. These are the numbers. Let's talk a little bit. With under 4 ohms, it was no power gain, but a lot of heat losing and stuff like that. I think the best result is until 4 ohms. Look here, with 5 ohms, we got 45 watts, half than the advertised power. Everything was happening at 33 volts, plus minus 33 volts. And I suppose if we use 35 or 38 volts like they asked in the pamphlet, maybe we got a gain of 5 watts or something. So this amplifier is not delivering more than 50 watts RMS. That's it. If I recommend it, no. No way. First of all, but anyway, just in case you are buying something like that, remember, take out the plastic, you know, put proper heatsink, put proper thermal isolation and transfer in the same time. Don't forget about a fan. Don't forget about a really heatsink, because you saw that in the first case here with 3.55 ohms, it was a lot of heat dissipation. And finally, no, just forget it. Buy TENGDA 7942 and you have a perfect amplifier, low distortion, good power and so on. Just forget it. Okay, I hope it's useful. I'll be back with new projects as soon as I have new ideas. In the meantime, please like, please subscribe. I need your comments too. If you are subscribing, and of course if you push like, you are helping the channel a lot. I need your help. And that's it. Okay, see you soon. Don't forget, have some fun, and don't burn your house.